Hello and welcome to this brand new fantastic amazing video. Today we're going to talk about PBF, policy-based forwarding. Now before we start looking at the configuration, which is really very simple, a quick overview. So first of all, what's the difference between PBR, policy-based routing, and these PBF? So PBRs are usually used on routers like Cisco, Juniper, and so on, and they are policies that specify the traffic. For example, I create a PBR where I tell it, look, before you read the routing table, check, direct, send the traffic to this destination. Then afterwards, check the routing table. That's PBR, simply put. PBF, on the other hand, is more or less the same thing, but it's based on policies. So I can specify the type of port, type of IP address, and so on, but I can also specify, for example, the application. And it remembers when you encounter this specific thing, for example, YouTube, send it to this destination, for example, the second line, if you have a provider, etc. And that's basically it. Now let's look at the configuration. So here we still have our fantastic lab, and here is provider 1, which is currently working, and here it is. Here it is, our trusty computer is pinging through provider 1. What do we want to do? We want to configure PBF to tell it that if provider 1 goes down, it should use provider 2. Now I know you might think, but I just set up 2 static routes and give one a higher metric. So if the first one goes down, it switches to the second router. Perfect, it works great. And you're absolutely right. But with the VRF we're about to configure and the PBF, what do we achieve? We get the same result. But in addition, instead of having a passive provider, so provider 2, which is in the same routing table, we can use it for other purposes. For example, VoIP or video. So if line 1 is up, it will keep using the primary line, but in the meantime, it can also use the second provider, which would otherwise just be sitting there doing nothing. We can use it for VoIP, for example. So this is a more optimal solution, so to speak. All right, let's go configure it. It's really quick to do. The first thing we need to do is configure the zone, because I already have the zones for provider 1 and provider 2. So if I delete it, I'll show you. Anyway, you know how to configure a zone, but I have to show you for obvious reasons. So ISP2, then type interface layer 3, and we add interface 1/3, which is the second provider, and done. Then the second thing, let's go create the policy so we can get it out of the way right away. Click add and write here ISP2. The traffic originates from the specified source, then proceeds towards the inside network, reaching its intended destination within a particular zone. This communication involves ISP2 utilizing any application, and the starting point is the source. Application any and service any. Okay? I'm moving it further up so you can see them all nicely lined up. Here, I'm renaming Internet to ISP2. Now, the configuration part itself is very simple. It's just the VRF part that might be a bit tricky, but I'll explain it to you. Let's proceed to NAT and meticulously configure the NAT settings. Here, you can clearly see there's NAT, which I will rename to NAT ISP1. Subsequently, we will carefully create the second NAT rule specifically for the new internet service provider, and we shall refer to it as NAT ISP2. See. For the original packet, the source zone will be designated as inside and the destination zone will be ISP2. The destination interface will be 1/3, which is precisely where I have connected my internet service provider's connection. Regarding the translation packet, we will utilize dynamic IP and port translation. The address type will be interface, specifically interface 1/3. The necessary IP addresses are assigned automatically by the system. And that's done. So we've created the policies and the NAT. Now, what do we have left to do? Now we have the most interesting part left to do. Virtual router, you'll probably have it like this, labeled default. Keep in mind that interface 1.3 is on the second provider. So default, we rename it and call it VRF1. and we remove this interface. We click OK, then click Add. We call it VRF2, and here we assign it interface 1.3. For example, this way of playing around and experimenting with VRF can also be used for VPNs. For instance, if you have more than one service provider and one is for VPNs, like Global Protect, you can create a separate routing table for Global Protect, so for the VPNs. This ensures that the data doesn't get mixed up as it would if you had a single routing table. And that's done. There's still a part missing here regarding routing, which I'll show you in a bit because it's a little tricky. So PBF. Now under policy-based forwarding, we go here, click Add, give it a made-up name, ASP1 source zone inside. Here we leave everything as default unless you want to specify something. It's the same for destination, application, and service. Everything is set to default, which is any. Obviously, unless you want to specify something. Forwarding. Egress interface. Here we select the interface where my provider is connected. In my case, 1/2, which is the first provider. Next stop. IP. Here I enter the IP address of my default gateway, which is this one. This is the internal IP address. Here you need to enter the public IP address of the provider. Then for monitor profile, you'll see that only default is available. In my case, I have failover, which you won't have, but if you want to create it, which you should, just click here on monitor profile, click, give it a name, select failover, and press OK. It's very simple, failover. Then here, you need to select this option, disable this rule if next hop monitor IP is unreachable, which means that if the first provider goes down, this rule will be disabled because it will then switch to the second one that we will create. So we enter Google's IP address and click OK. Then we create the second rule, ISP2. Sorry for a bit of rambling. Then here we set it to inside. Then everything else is left as default. Forward to my second provider, which is on interface 1.3. Next hop IP address. Here we enter the default gateway of the other provider. But this time, however, here we specifically don't select monitor. I would only select this particular option if I had a third line available. Then we simply click OK, and that entire process is completely done. Now let's move on for a moment to the slightly more intricate and potentially trickier part of our configuration, VRF. When you are working with VRFs, it is absolutely crucial to understand that VRF1 inherently doesn't know the specific networks that are connected to VRF2, and conversely, VRF2 doesn't know the networks connected to VRF1. So you absolutely have to explicitly tell it, and we accomplish that essential task with a static route. So let's proceed to go into VRF1, navigate to the static route section, and then click the Add button. Here we will call it Return Path. You have the flexibility to give it any descriptive name you want. Here, we critically need to enter the subnet address of our provider, which in my specific case is 37.0/24. Thank you very much. Yours might be a /29, for example, if you have more than one specific IP address, or a /32 if you have only a single IP address. In any case, you absolutely need to carefully enter the correct subnet. Then for the interface, we don't put anything here at all. For the next hop IP address, we specifically select next VR, and here VRF2 will automatically appear. So I've clearly told it that if it ever wants to reach that particular network, which is indeed my provider's network, it needs to explicitly ask VRF2 for assistance. Meanwhile, on VRF2, which currently doesn't know anything about my internal network, there's also a crucial static route still missing in VRF2, and that of course is the default gateway. I'll add it right away because I did it earlier and completely forgot about it. So the default gateway is set to 0.0.0.0/0, utilizing interface number 13 with an assigned IP address of 10.0.137.1. All right, so here, you need to tell it if it wants to reach the 192.168.80.0 network. So I also call this the return path here. Destination, now I have to necessarily enter this subnet here, but if you had more than one network address, so multiple addresses, multiple subnets under the interfaces, for example, you could do 00.16. This way it will take them all, or alternatively you can make 2, 3, 4, or even 5 separate static routes, but truly that's just a significant waste of valuable time. /24, okay. Then carefully leave the interface blank and proceed to set the next VR. Let's specifically put VRF1. And now the system inherently knows that if it ever wants to contact the 132.168.80.24 network, it absolutely has to ask the designated VRF for routing information. So I think we've successfully done everything that is required. Commit the changes. The computer is still here pinging. And now let's carefully observe what precisely happens next. Meanwhile, let's proceed directly to the monitor to view the live feed. Let's give it just a moment to, fully apply all of the necessary changes. Once that particular task is completely done, we can, so to speak, proceed to conduct a little, perhaps even a small experiment. So as you can clearly and distinctly see here within the dialog box, it explicitly states ISP1, indicating that it is currently routing through ISP1. However, the critical issue is that ISP1 is currently and unfortunately completely dead. All right, let's carefully observe what precisely happens next. So it initially lost a single ping and then continuously keeps pinging, which indicates it definitely performed the switch. But are we absolutely certain it actually successfully switched over? Yes, just look at the logs here and you'll see that it definitely switched, because otherwise it couldn't be pinging. If it was still pinging, I'd be surprised to know how. And you'll see that ASP2 will appear, so it's using the ISP2 policy and the traffic is going through there. But if we reconnect ISP2, obviously you think, of course, it will switch back. Yes, it does indeed switch back, but not immediately, because the continuous data flow persists and established TCP connections, or in this particular case, ICMP, remain active. On the VRF2 routing table, and until it has cleared the queue, it won't immediately let you switch over to that other router. But you'll see that at a certain point here, it will say SP1. There you go. See, SP1, here it is, it's back. Now, the big advantage, as I mentioned earlier, with this type of configuration is that provider 2 is active, you can use it, and then you can do whatever you want. For example, if I go back here and go to policy and tell it that I want to route certain traffic from inside to SP2, I can easily do that. And now in this case, as you can see, all the applications are there. But if I specify here, for example, only HTTP and HTTPS and have the rest go through here, it will do that. This clearly translates into a speed advantage. And above all, you keep the data separate, especially if you use VoIP, YouTube, all the videos and so on. The last recommendation I have for you is to use policies based on applications, not on ports. And I'll tell you one last thing before we say goodbye. For those who don't know, for example, here you can see all the applications. All these applications use their default ports. HTTPS uses 443. Then there's this one here, LinkedIn, for the LinkedIn application, which I believe will always use 443. But in any case, they use the default ports. Well, if you configure the application this way, and you get the brilliant idea to set a port like 8080, and hit apply, you'll see that everything stops working. Everything stops because it automatically associates the application with that port. So for example, HTTPS, which is on port 443. If you wanted to open Google, you'd have to type something that doesn't work. There are some sites that do work, but basically you'd have to type Google:8080, otherwise it won't work anymore. My recommendation is use the rules, the policies like application inspection, because they give you greater security. So guys, I hope this video was useful to you, that it can help you solve some problems if you have them. If you liked the video, leave a like. If you're not subscribed to the channel, subscribe. And if you want to help the channel grow, share the videos with your friends or on your social media. It doesn't cost you anything, but it helps my channel grow. Thank you and see you next time. If you have any comments, of course, write them down. Bye!